see, there is no lag, there is no initialization time. It's just there. And even better, because you're cooling the CPU, and because you're doing things efficiently and more productively, you get about a 60% less consumption of your battery as a result of doing augmented reality operations. So this was awesome to us. And looking at this as part of our vision of the augmented city, we made it so that this piece of hardware would be customizable and modular to nearly any semiconductor platform. So that's all the way from smartphones and tablets to things like wearable computing to embedded systems like cars. So we're really looking to the future with this, and we're currently the only augmented reality company that's doing this. We're the only one that's really trying to, and it's not like we want to make chips. We want to design them, and we want to work with companies like Intel, NVIDIA, Epson, to try and figure out how this fits into existing hardware ecosystems to really make it better.
Cool.
It's pretty cool. I sort of brought up a few issues, and you can think of these as you're doing your hacking. The first, of course, is form factor, we talked about. And that's more something for the hardware companies to figure out. But form factor will have to do with your experience. So for instance, if you have something where you can't move, you can only turn around in a 360-degree environment, like the AR Quake. Or if you're attached to a PC, and some of those industrial examples, it limits your movement. And that's the really cool part about these mobile devices, Moverio and possible future iterations, the Vuzix, the Google Glass, is it allows you to be mobile and allows you to craft your experiences and have a greater degree of accessibility. One thing that I keep thinking of is the GUI. What's the user interface of these things in the future? Because I've seen probably 10 different wearable computing prototypes, and it's like, I don't know if any of you guys, who's used Google Glass so far? Who's used Google Glass for more than an hour? That's what I thought. There's a couple reasons for that. One is it's the most frustrating user interface I think I've experienced since I don't know, Windows. And it's, sorry for all you Windows lovers, I'm just kidding. Really, you sit there and you're cycling through, and it's sort of this very sensitive touch interface. And there were times where I scratch my ear and it does something. I'm like, I don't want you to do that, Google. And for some reason, it doesn't really listen to you as well. Because you say, okay, Glass, and you can't say, well, not okay, Glass. Actually, I don't want you to start. So the end result is you're sitting around doing this the entire time, and it's not
Oh,
bad.
that's a good video.
So that's one of those things. So how's the GUI? Because the thing is, you have an iPhone app or an Android app, and you have touch. Touch gives us a lot of capabilities and possibilities. When you no longer are using your hands, let's say in a non-meta environment where you don't have depth interaction, if you're not using your hands and you want to not use your hands, how does the user navigate through the experience? This is not an issue for passive experiences because you just look at something and something happens. But if it's experiential, if you're trying to do things, it's something that I just even moving forward in the years to come that I want developers to consider. How can we really conquer this kind of GUI issue? And I think it's going to come partly in platform, but also I think will come through just the hardware itself. Platforms. There's a lot of platforms out there, and I think there's different ways to go about it, but sometimes native's good. Sometimes you want to use you want to piggyback it through a Windows PC or something, but there's a lot of platform issues, and that's what we really like about our SDK, which we'll get into in a second, is that it's not a platform like Android or iOS. It's basically a collection of libraries and algorithms that allow you to take that and integrate it into native platforms. And that's one of the reasons that we were so adamant about doing that instead of sort of piggybacking it onto another platform, is we want that sort of versatility for the developer. And because we never think that we're smart enough to know the next 5 years of a given ecosystem. I mean, right now, mobile is going to all sorts of different areas with wearable computing. So why take that platform and say, this is only iOS? What about wearable computing systems that don't run iOS? What do you do then? So once again, interesting to see which platforms are better for what. We're actually the only platform that has 3D object tracking, which, when you think about it, is something very, very necessary for wearable computing, for any kind of headset, because you want to be able to recognize something without doing anything with your hands. So how do you do that? It needs to be very intuitive, it needs to be very robust. And of course, hardware. That's for people like Eric and Anna. Battery life. Interesting about Google Glass. If you try to use an augmented reality experience on Google Glass, you're going to need your charger handy or power outlet because it'll be gone in about 45 minutes, tops. If it lasts 45 minutes, I'll give you a medal. because it's really, it just goes away. And that's because it'll also possibly burn the side of your face, because once again, that CPU, all that, it's a non-optimized system. That CPU is heating up, and we don't mean that figuratively. We're talking like if you were to use an always-on, always augmented experience on, say, an iPhone, maybe even like a multi-core iPhone, and you try to use it all day and you charge it in, the CPU might actually melt at the back of your phone. I'm not even kidding. We're talking about like 3,000 picojoules of work happening on a CPU simultaneously with no parallelization. There's a lot of big words, but that's basically a lot of work. It's a near Sisyphean task for the CPU to do. It never gets easier. It only gets harder. So there you go. So those are the kind of the considerations that I think all of you should have, regardless of the things that you come up with. So we are very happy to be here. We're so happy we're going to give some stuff away for free.
Great.
If you're lucky. As part of that is this SDK, the Moverio SDK, which I sort of mentioned, but just to give you a rundown on it. Is both, it has native environment capabilities, so you can develop it in native environments for iOS and Android. It supports Unity, if you're into that kind of 3D content. It supports cloud-based content and offline content, which means that if you'd like to cache or just store the content in the app itself so you can access it without an internet connection, you can do that, or vice versa. You can serve it to the cloud like the IKEA app. It is the only SDK that has 3D object tracking, both like a priori 3D tracking, where you have an object in a static environment, you train the point cloud, and you can basically use that to recognize it, and or dynamic reality capture, or SLAM, which is when you come to a new environment, you on the fly make a point cloud and you insert the information in a database for a specific city. What we are doing though is we're looking at ways, because there's actually a lot of databases with point cloud information about cities. There's LiDAR, there's a company in the Bay Area called Hover that's also working on user-generated 3D information of cities. And the idea is really, instead of going out and doing that ourselves, or getting someone else to do it, they're to tap into these existing databases. So you're actually walking around, and every time you're in a new environment, you can just pull that data from the cloud on the fly and basically like cycle through it. And that's the kind of vision. So I mean, we've taken point clouds of entire buildings, like the Marienplatz in Munich, the city center, to basically overlay stuff onto that. But the cool thing about the SLAM and the dynamic reality capture is that you don't need to have pre-trained point clouds. You can just do it on the fly. So you're looking at a surface and it's creating the point cloud as you move around, and using it for that given experience, and then you move on to the next one and it does it again, deletes the old one, so on and so forth. So that's really, there's a couple different approaches.
Is there better quality when you use something like LiDAR versus camera tracking? You're talking about camera tracking, right? That's the
Well, talking about just like pulling point cloud data from the cloud.
I guess that the point cloud generated by camera tracking versus like LiDAR. I don't know if you have...
LiDAR is probably, the thing is like when you're generating it by the camera, you don't really control like what points you're getting. So the nice thing about LiDAR is that it's a little bit more robust and sophisticated, and it's like productive in a sense. So if you can pull that from the cloud, you have more points of recognition. Versus when you're learning, it's pretty good, but it's not as good if you have that data existing somewhere already.
How are you spelling LiDAR?
I believe it's LIDAR.
Also, I mean, there's a lot of information there as well. Is there anything like, you have like, for example, geometry, you kind of like low poly stuff in order for, for memory. Do you do that
Yes.
anything with like LiDAR, for example, or
Yes,
cloud
I mean,
data? How does it handle that? I mean,
Yeah, so what we're doing right now is we're working on something that we call a snapping algorithm. When you would pull down basically like a low polygon information for whatever the place that you are in, and using a combination of GPS and camera tracking, you would essentially lock that in to whatever the real world reference is, and then it's just the most tightly aligned thing you've ever seen. I can actually show you guys a video if you want, but it's really cool because it basically faces the need for a lot of like heavy content creation. The whole like going out to every city and making a point cloud and like storing that somewhere, and it also is extremely intuitive for the user because they use that kind of GPS navigation to get to a place. And when GPS is no longer a viable way, because you're looking at a thing and you have a 3D model of it like scattering around over here, to actually take that and combine them and then your phone basically just knows that's there and it will never leave. So you have no jumping or lagging or anything. It's really so that's in our R&D pipeline. Does that answer your question?
Can you extract the data from like Google Earth?
Yeah, if Google Earth would let you do that. But we could probably do some crazy data mining with like Python or something, but none of the engineers are that committed.